Hello students, very good morning. Welcome to Narayana Live Classes. Today for class 10 students, we are going to discuss assignment number 16 on properties of binomial coefficients. Let us start with the first question. If 1 plus x square whole power n is sigma r is equal to 0 to 2n ar x power r, then what is the value of a0 plus a2 plus a4 plus so on plus a2n? Let us start the solution. What is given for us? 1 plus x square whole power n, that is going to be sigma r is equal to 0 to 2n ar x power r. If I expand this, I am going to have a0 plus a1x plus a2x square plus so on plus it ends with 2n, so r 2n means a2n into x power 2n. Fine, let me take this is a given. Now let us take x is 1. To take x as 1, 1 plus 1 plus 1, that is 3. 3 power n is going to be a0 plus a1 plus a2 plus so on plus a2n. Consider it as condition number 1. Similarly, we put x as minus 1, then we have 1 minus 1 0, 1 square minus 1 square is 1, 1 power n is 1 itself. So this is 1 is equal to a0. Here it is a1 into minus 1. So we are going to have minus a1 plus a2 minus a3 plus so on plus a2n. That is second condition, because a2n y plus minus 1 whole power 2n, which is even. 2n is even. So minus 1 power even is plus itself. So plus a2n. So 1 and 2. What do you need now? a0 plus a2 plus a4. a0, a2, a4 means these two must be cancelled. So add up these two conditions. If you add up these two, 1 plus 2, you do 1 and 2, if you add up them, what you are going to have? 3 power n plus 1 is going to be 2 times of a0 plus a2 plus so on plus a2n. 2 times of a0 plus a2 plus so on. What do you need now? a0 plus a2 plus a4 plus so on, a2n you need. So this 2 you transpose here, that becomes 3 power n plus 1 by 2. 3 power n plus 1 by 2 is nothing but first option for us. That is the right answer for given required a0 plus a2 plus so on plus a2n. Okay. Now let us see the next question. The value of the summation sigma k is equal to 1 to n, sigma r is equal to 0 to k, r into NCR is. Interesting question. Sigma k is equal to 1 to n, sigma r is equal to 0 to k, r into NCR. Okay. That is going to be, we have NCR, we can write as n into n by r into n minus 1 c r minus 1. This property we have. NCR can be written as n by r times of n minus 1 c r minus 1. Let me use it. So if I use that, it is going to become sigma k is equal to 1 to n, sigma r is equal to 0 to k, r into n by r. It is simply n times of n minus 1 c r minus 1. Okay, here it is depending on k, independent of n. So n will come out, n times sigma k is equal to 1 to n. Now this sigma notation, if at all you are trying to apply, r is running from 0 to k. Anyway, r0 is not valid. We have to take r from 1. So what do you get if r from 1? If you take n minus 1 c0 plus next n minus 1 c1 plus so on plus n minus 1 c k minus 1. That will be the last term in the summation. Fine, because r if you replace with k, that is k minus 1, that will be the last term. Again we have one more summation. K is 1 to n. It is depending on k. It is not independent of k, it is depending k. Okay, what to do now? Here let me show you one thing. If at all I take the last term, what is last term? Sigma. Okay. K is 1 to n, he is saying. K is 1 to n, because this sigma notation can be applicable for this term, all the individual terms, because in between we have plus sign. So let me take sigma k is equal to 1 to n, last term n minus 1 c k minus 1. n minus 1 c k minus 1. If you start running the k value 1, so it starts with k1 means n minus 1 c0 we get, plus n minus 1 c1 we get, plus n minus 1 c2 we get, and we end up with n minus 1 cn minus 1. This term alone gives you this expansion. If at all you take sigma k is equal to 1 to n minus 1, c k minus 1 minus 1, that is k minus 2 if you take, that starts with n minus 1 c0 plus n minus 1 c1 plus so on plus n minus 1 c n minus 2. Okay, because here n minus 2 is the n term. Because every term we are going to have n minus 1 c0 common, followed by n minus c1. So gradually what is happening? N minus 1 c n minus 1 only once it is appearing. Its before term will be definitely n minus 1 c n minus 2. Its next term will be n minus 1 c n minus 3. Means n minus 1 c n minus 2 is appearing only 2 times. 2 times. So it is interesting. If at all you write it, then n minus 1 c0 here we have, and all these cases, in this case also n minus 1 c0 appears. So n minus 1 c0 is going to be appearing n times in the expansion. Similarly, n minus 1 c1 is going to appear in n minus 1 times in the expansion. N minus 1 c2 is going to appear n minus 2 times, so that n minus 1 c k minus 1, that is n minus 1 is going to appear one time. One time is nothing but n minus of n minus 1 times. So let me write that. So if at all I want that, let me write in this. I use this space for that. So that is equal to, here we have n minus 1 c0 is appearing how many times? N times. So let me write that. That is equal to n times of n minus 1 c0. Okay, plus n minus 1 times of n minus 1 c0 plus n minus 2 times of n minus 1 c1 here, n minus 1 c2 plus so on plus n minus of n minus 1 times of n minus 1 c n minus 1. This is very, very important. That is otherwise, if you look at that, it is in the form of a into n minus 1 c0. Okay, AC0, otherwise let me write like this, AC0 plus A plus D C1 plus so on plus A plus ND times of, okay, Cn. That is going to be 2A plus ND times of 2 power n minus 1. This expansion already we learned in examples. AC0 plus A plus D times of C1 plus so on plus A plus ND times of Cn is going to be 2A plus ND times of 2 power n minus 1. In this case, A is n. Okay. In this case, A is n. A plus D is going to be n minus 1. So A is n. Therefore, D is minus 1. Okay. Therefore, its entire summation, if you want, that is n times of 2A. That is 2n plus n. N is n minus 1 here. N minus 1 times of D is minus 1 times of 2 power n minus 1. N is n minus 1. So n minus 2. Wherever you have n, replace with n minus 1. So that is going to be n into, here 2n minus n plus 1, that is nothing but n plus 1 into 2 to the power of n minus 2. So the value becomes n into n plus 1 times of 2 power n minus 2. That is nothing but, here we have to say, n into n plus 1 times of 2 power n minus 2 is nothing but second option for us. So second option is the right answer. So this is very, very crucial. Two sigma notations, and here both are not independent. This is not independent. K means K is 1 to n. Both are dependent on, this is dependent on this. So we must be little careful in solving this. Okay. Now let us see the next question. If 1 plus x square whole power n is similar question like first question only, but here these are changed. A1 plus A3 he is asking. There we found A0 plus A2. Now what to do? 1 plus x square whole power n, that is going to be, let me write, A0 plus A1x plus A2x square plus A3x cube plus so on plus A2n. Its before term will be A2n minus 1. So put x is 1. Here export 2n also we have, right? Put x is 1, then what you have? 3 power n is going to be A0 plus A1 plus A2 plus A3 plus 1 plus A2n minus 1 plus A2n. Let me write this condition number 1. Now let us take x as minus 1. If x is minus 1, we have 1 minus 1 0, and it is 1 of course. A0 minus A1, okay, plus A2 minus A3 plus so on minus A2n minus 1 plus a to n. Why it is minus 2 and minus 1 is odd? Minus 1 power odd is minus 1 of course. Here what do you need now? A1, A3. A1, A3. Means these two must be there, means don't add, subtract. 1 minus 2 if you do. Subtract. Implies we have 3 power n minus 1 is going to be 2 times of A1 plus 2 times of A3 plus so on plus 2 times of A to n minus 1. So throughout to common. So A1 plus A3 plus so on plus A to n minus 1 is how much? 3 power n minus 1 upon 2. That becomes a required answer. 3 power n minus 1 by 2 is nothing but second option for us. That is the right answer for this question. Okay. Now let us see the next question. Sum of the last 20 coefficients in the expansion of 1 plus x whole power 39 when expanded in ascending powers of x. We can write this as 39c0 plus 39c1 times of x plus 39c2 times of x square plus so on plus 39c19 times of x power 19, let me split like this, plus 39c20 times of x power 20 plus so on plus 39c39 times of x power 39. As the power is 39, overall how many terms will be there? The number of terms will be one more than the binomial power. That is 40 terms will be there. In that 40 terms, here these are first 20 terms and these are next 20 terms. First 20 and next 20. Fine? Means here 39c20 value is equal to 39c19. Both are equal. NCR is NCS. What is the rule we have? NCR is NCS if N is R plus S. If R plus S is N, then definitely NCR and NCS are same. So take 19 and 20. 19 plus 20 is 39. So 39 is same. So 39c20 is equal to 39c19. Similarly, 39c21 will be equal to 39c18. It goes on like that. 39c19 is 39 is equal to 39c0. Okay? If at all you take the coefficients, this coefficients, that is how we can equate. Put x is 1. If you take x as 1, 2 power 39 is going to be 39c0 plus 39c1 plus so on plus 39c19. This is one set plus 39c20 plus 39c21 plus so on plus 39c39. Just now I told you, sum of all these values will be equal to these values. These two are equal. These two values are equal. Okay, why 39c20, 39c19 equal, 39c21, 39c18 equal, so on, 39c0, 39c39 are equal. So we can write it as 2 times of this whole, that is that 39c20 plus 39c21 plus so on plus 39c39. What are these? Last 20 coefficients, sum of the last 20 coefficients. These are the last 20 coefficients. This is what he is asking us. So this into 2 times is 2 power 39. So if you want only this part, 2 you have to transpose here. So that becomes 2 power 38. That is going to be 39c20 plus so on plus 39c39. So sum of the last 20 coefficients of the expansion 1 plus x whole power 39 is going to be 2 power 38. 2 power 38 is nothing but fourth option for us. So that is the right answer. Okay. So that is the end of this assignment. Thank you. Have a great day.